Hi and welcome back to our course on modern manufacturing. This is the third lecture in this course. In the last two lectures, we had learnt about manufacturing, manufacturing industries, manufactured products, production quality, product variety, and manufacturing capability, along with materials in modern manufacturing. In this lecture, we will learn about manufacturing processes. First, we will look at what is a manufacturing process, classification of manufacturing processes, overview of processing and assembly operations. We will also get into a bit of details about material processing, that is, shaping, property enhancing, and surface treatment. And then we will talk about production machine and tooling. So, what is a manufacturing process? A manufacturing process is a designed procedure that results in physical or chemical changes to a starting work material with the intention of increasing the value of the material. A manufacturing process is usually carried out as a unit operation, which means that it is a single step in the sequence of steps required to transform the starting material into a final product. Manufacturing operations can be divided into two basic types. First is processing operations and second is assembly operations. The processing operations transform a work material from one state of completion to a more advanced state that is closer to the final desired product. It adds value by changing the geometry, properties, or appearance of the starting material. In general, processing operations are performed on concrete work parts, but certain process operations are also applicable to assembled items. For example, painting a spot welded car body. An assembly operation joins two or more components to create a new entity called an assembly, a sub-assembly, or some other term that refers to the joining processes. For example, a welded assembly is called a weldment. Now, more than one processing operation is usually required to transform the starting material into a final form. The operations are performed in the particular sequence required to achieve the geometry and condition defined by the design specification. There are three categories of processing operations: shaping operations, property enhancing operations, and surface processing operations. Now, shaping operations alter the geometry of the starting work material by various methods, which include casting, forging, and machining. Property enhancing operations add value to the material by improving its physical properties without changing its shape. Heat treatment is the most common example. Surface processing operations are performed to clean, treat, coat, or deposit material onto the exterior surface of the work. Common examples of coating are plating and painting. Shaping processes. Most shape processing operations apply heat, mechanical force, or a combination of these to effect a change in geometry of the work material. There are various ways to classify the shaping processes. We will discuss on the four basic categories. 1. Solidification process, in which the starting material is a heated liquid or a semi-fluid that cools and solidifies to form the part geometry. Particulate processing, in which starting material is a powder and the powders are formed and heated into the desired geometry. Third, deformation process, in which the starting material is a ductile solid that is deformed to shape the part, and finally material removal processes in which the starting material is a solid from which material is removed so that the resulting part has the desired geometry. In solidification process, the starting material is heated significantly to transform into a liquid or highly plastic state. Nearly all materials can be processed this way. Metals, ceramic glasses, and plastics can all be heated to significantly high temperatures to convert them into liquid. With the material in a liquid or solid form, it can be poured or otherwise forced to flow into a mold cavity and allowed to solidify, thus taking a solid shape that is same as the cavity. Most processes that operate this way are called casting or molding. Casting is the name used for metals, while molding is a common term used for plastics. In particulate processing, the starting material are powders of metals or ceramics. Although these two materials are quite different, the processes to shape them in particulate processing are quite similar. The common technique involves pressing and sintering, in which the powders are first squeezed into a die cavity under high pressure and then heated to bond the individual particles together. In deformation processes, the starting work material is shaped by the application of forces that exceed the yield strength of the material. For the material to be formed in this way, it must be sufficiently ductile to avoid fracture during deformation. To increase ductility, the work material is often heated before forming to a temperature below the melting point. Deformation processes are associated most closely with metalworking and include operations such as forging and extrusion. Material removal processes are operations that remove excess material from the starting workpiece so that the resulting shape is the desired geometry. The most important processes in this category are machining operations such as turning, drilling, and milling. These cutting operations are most commonly applied to solid metals, performed using cutting tools that are harder and stronger than the work metal. Grinding is another common process in this category. Other material removal processes are also known as non-traditional processes because they use lasers, electron beams, chemical erosion, electric discharges, and electrochemical energy to remove material rather than cutting or grinding. We will also learn about these processes further in our course. It is desirable to minimize waste and scrap it in converting a starting work part into its subsequent geometry. Certain shaping processes are more efficient than others in terms of material conservation. Material removal processes tend to be wasteful of material simply by the way they work. The material removed from the starting shape is waste, at least in terms of the unit operation. Other processes such as casting and molding operations often convert close to 100% of the starting material into a final product. Manufacturing processes that transform nearly all the starting material into the product and require no subsequent machining to achieve final part geometry are called net shape processes. Other processes require minimum machining to produce the final shape and are called near net shape processes. Now let's look at property enhancing processes. The second major type of part processing is performed to improve mechanical or physical properties of the work material. These processes do not alter the shape of the part, except unintentionally in some cases. The most important property enhancing processes involve heat treatment, which include various annealing and strengthening processes for metals and glasses. Sintering of powdered metals and ceramics is also a type of heat treatment that strengthens a pressed powder metal work part. Surface processing operations include cleaning, surface treatment, coating, and thin film deposition processes. Cleaning includes both chemical and mechanical processes to remove dirt, oil, and other contaminants from the surface. Surface treatments include mechanical working such as shot peening and sandblasting, and physical processes such as diffusion and ion implantation. Coating and thin film deposition processes apply a coating of material to the exterior surface of the work part. Common coating processes include electroplating, anodizing of aluminium, organic coating, and porcelain enameling. Thin film deposition processes include physical vapor deposition and chemical vapor deposition to form extremely thin coatings of various substances. Several surface processing operations have been adapted to fabricate semiconductor materials into integrated circuits for microelectronics. These processes include chemical vapor deposition, physical vapor deposition, and oxidation. They are applied to very localized areas on the surface of a thin wafer of silicon to create the microscopic circuit. The second basic type of manufacturing operation is assembly, in which two or more separate parts are joined to form a new entity. Components of the new entity are connected either permanently or semi-permanently. Permanent joining processes include welding, brazing, soldering, and adhesive bonding. They form a joint between components that cannot be easily disconnected. Certain mechanical assembly methods are available to fasten two or more parts together in a joint that can be conveniently disassembled. The use of screws, bolts, and other threaded fasteners are important traditional methods in this category. Other mechanical assembly techniques form a more permanent connection. These include rivets, press fitting, and expansion fits. Special joining and fastening methods are used in the assembly of electronic products. Some of the methods are identical to or are adaptations of preceding processes, for example, soldering. Electronics assembly is considered primarily with the assembly of components such as integrated circuit packages to printed circuit boards to produce the complex circuits used in many of the today's products. Manufacturing operations are accomplished using machinery and tooling. The extensive use of machinery in manufacturing began with the Industrial Revolution. It was at that time that metal cutting machines started to develop and widely used. These were called machine tools, power-driven machines used to operate cutting tools that were previously operated by hand. Modern machine tools are described by the same basic definition, except that the power is electrical rather than water or steam, and the level of precision and automation is greater today. Machine tools are among the most versatile of all production machines. They are used to make not only parts for consumer products but also components for other production machines. Both in a historic and reproductive sense, the machine tool is the mother of all machinery. Other production machines included presses for stamping operations, forge hammers for forging, rolling mills for rolling sheet metal, welding machines for welding, and insertion machines for inserting electronic components into printed circuit boards. The name of the equipment usually follows from the name of the process. Production equipment can be general purpose or special purpose. General purpose equipment is more flexible and adaptable to the variety of jobs. It is commercially available for any manufacturing company to invest in. Special purpose equipment is usually designed to produce a specific part or product in very large quantities. The economics of mass production justify large investments in special purpose machinery to achieve high efficiency and short cycle times. This is not the only reason for special purpose equipment, but it is a dominant one. Another reason may be because the process is unique and commercial equipment is not available. Some companies with unique processing requirements develop their own special purpose equipment. Production machinery usually requires tooling that customizes the equipment for the particular part or product. In many cases, the tooling must be designed specifically for the part or product configuration. When used with general purpose equipment, it is designed to be exchanged. For each work part type, the tooling is fastened to the machine and a production run is made. When the run is completed, the tooling is changed for the next work part type. When used with special purpose machines, the tooling is often designed as an integral part of the machine because special purpose machine is likely being used for mass production. The tooling may never need changing except for replacement of worn components or for repair of worn surfaces. The type of tooling depends on the type of manufacturing process. In the coming lectures, we will learn in detail about each of these manufacturing processes. Thanks for watching this lecture. See you in the next one.